In this lesson, you'll learn about the remainder theorem. The remainder theorem tells us if a polynomial p of x is divided by x minus c, then the remainder will be p of c. So there's a couple of things going on here in this sentence. We're talking about some division, and if we're talking about p of c, we're talking about some evaluating. It's kind of hard to see what's going on without a polynomial to actually look at. So let's do that first. Let's give ourselves a polynomial p of x, and how about 5x squared plus 3x? And then let's give ourselves a binomial to divide into p of x. Let's just do x minus 2. So let's evaluate p of x for p of c. We've got to look over here at this binomial, so it'll be p of 2 that we're evaluating. C is going to be a positive 2. Because this is x minus c, and we're just evaluating for the c, you can think of this as a sign change if you want to. But if you have a minus 2, it'll be positive 2. If you have a positive 2, it'll be negative 2. So let's go back over here to p of 2 and evaluate. 5 times 2 squared plus 3 times 2, and let's see what that equals when we simplify. That's 5 times 4 plus 2 times 3 is 6, or 4 5s are 20 plus 6 is 26. Now let's see what this is supposed to tell us. If we evaluate p of 2, then that should be the same value as the remainder when we divide x minus 2 into our polynomial 5x squared plus 3x. And let's see if that really happens. We could use synthetic division or long division. I'm going to go ahead and use synthetic division on this one. So I'm going to divide 5x squared plus 3x, and I'm going to go ahead and put a placeholder for the constant. That helps with synthetic division. So we've got 5x squared plus 3x plus 0, and we're going to divide this by our x minus c, or in this case, x minus 2. So I'll line up the coefficients, 5, 3, and 0, and then I'm going to put a 2 here with a sign change and evaluate. The first thing we do is bring the 5 down, and then it's multiplication. It's the 2 times the 5 gives 10, and then it's addition for synthetic. So 3 plus 10 is 13. 2 times 13 is 26. Again, it's addition, and our remainder is 26. The remainder theorem told us these would be the same values. The 26 remainder would be the same as if we evaluated the function for p of c, or p of 2. So it did work. What does this really tell us, though? Well, for one thing, sometimes it's easier to evaluate easier and faster than doing some sort of division. So if we want to know something about the remainder, it might be quicker to just go ahead and evaluate and see what the remainder is if we're not looking for the actual equation but just the remainder. There's different uses for the remainder theorem, but in this lesson the main thing we want to use it for is to find out if the binomial is actually a factor of the polynomial. And we can tell that because if we get a number other than 0, we know that our binomial is not a factor of the polynomial. Right here we can tell that x minus 2 is not a factor of 5x squared plus 3x because 26 is not a 0. Let's take a look and see how we can use the remainder theorem to figure out which of these 4 binomials is a factor of f of x. We'll have to evaluate f of negative 3, and pay attention that from here to here there's a sign change. So that'll give us negative 3 squared, the square has to be on the outside of the parentheses, otherwise it's a different value, plus 5 times negative 3 plus 6, and let's simplify this to see what we get. Negative 3 squared is 9, 5 times negative 3 is negative 15, and then a plus 6, and if I add 9 and 6 I get 15, and then take 15 away I get a 0. That tells me that x plus 3 is a factor of f of x. So that's going to work. Now let's take a look at the next one. We'll evaluate f of negative 1, and that'll give us negative 1 squared plus 5 times negative 1 plus 6. Now we're getting that from our f of x up here. And that's going to give negative 1 squared is positive 1, 5 times negative 1 is minus 5, and a plus 6 here at the end. The 1 and the 6 give us 7, take away 5 gives 2. So this is a no, this is not a factor. X minus 2, so we're going to evaluate f of positive 2. If we do that, we get 2 squared plus 5 times 2 plus 6. Now I'm not putting 2 squared in parentheses, I could, but there's no negative sign to change anything or to have to think about, so it's just 2 squared. 2 squared is 4, 2 5s are 10, and then plus 6, and I can see that's not going to equal 0, but 4 and 10 is 14, plus 6 is 20. We'll go ahead and finish it. So the answer there is no. And then down to the last one, we've got x plus 2. We've got to evaluate f of negative 2. And that's going to give negative 2, I need those parentheses because of that negative sign, plus 5 times negative 2 plus 6. And that's going to give negative 2 squared is 4. 5 times negative 2 is negative 10, and a plus 6. If I add my 4 and my plus 6, I get 10, and take 10 away, I get a 0. So this one is also a factor. X plus 2 is a factor. Now I know that the problem is just asking which of the following are factors, but before we wrap up this problem, let's look at one more thing here. Let's say we're solving x squared plus 5x plus 6 equals 0. One way to solve this quadratic equation would be to factor it, so let's do that. And we already have the factors. We found the two factors for the quadratic, so it's x plus 2 and x plus 3. And then to solve this, we would take each of these factors and set them equal to 0. And that would give us x equals negative 2 and x equals negative 3. So what you should notice here is that you've not only found the factors of the equation, but you've also found its roots. The factors are x plus 3 and x plus 2. And the roots are x equals negative 2 and x equals negative 3. Now you know a bit more about the remainder theorem. See you next time.